Hello, thank you for joining me. So in this video I'd like to show you a little bit more about geometric dimension and tolerancing and what happens when we have a dimension that defines maybe the diameter of a pin that goes into a cylindrical hole, and what happens when that diametrical dimension is true all the way throughout a non-cylindrical item like this. We need something extra that helps define this a little bit better, and that's what geometric dimension and tolerancing tries to do with feature control frames, and we'll talk about that here in just a minute. But for demonstration, let's take this part and take a look at this. I've deliberately taken the cylinder, this cylindrical pin, and I've put a flex tool on it so it's kind of like bent in the middle. And let's take a look at that. If we go to a cross-section of it, we could see something that's happening. We have a gap up here. We have interference over here. So we have clearance on one side and interference on the other side. And the same thing down here. So right down the middle, then we have an appropriate amount of clearance. But down here we don't. We have interference there. We have clearance over here. If we were to try to take this bent cylinder and try to put it in the hole, we'd have a difficult time on it. Now again, this the diametrical dimension that defines this at each cross-section is true, but it's not cylindrical. So what we try to do in geometric dimension and tolerancing is to try to define a feature. If you think about the dimensions that go with this, here's our 0.65 dimension we've been talking about. We talk about these dimensions here. That is essentially a 2D dimension. A feature control frame defines the 3D feature. And so what we're going to do is we're going to put a feature control frame on the cylindricity of the cylinder of the cylindrical pin. And we're going to put that in a drawing format. So understand those concepts. The dimensions typically define a 2D cross-section, a 2D dimension, whereas a feature control frame defines the 3D aspect of the part we're trying to draw. So we're stepping out of the 2D world that we were in AutoCAD and stepping into the 3D universe of SolidWorks, and we need to define these things a little bit better. So let's go and open up a drawing that shows this a little bit better. Okay, so here's our pin and here's our block. We put them into the same drawing, and here's our feature control frame. I'm going to go ahead and erase this and put a new one in, but let's talk about, before we do that and how we do it, let's talk about some of the concepts involved. Here's our dimension, 0.625, and our limit tolerance on that, as you can see over here, can vary by 0 on the one end. So it's going to be the basic dimension, and on the lower end of that could be as small as 0.620. So that pin could be at the basic dimension or smaller than that in order to fit inside the hole. But here's a feature control frame, and the feature control frame defines the feature control frame defines the 3D aspect of that. So what we're saying is that and this reads from left to right, cylindricity with a tolerance of, the variation that we're allowing of 0.202 inches or 20 thousandths of an inch. So it has that variation to it. So between the top and the bottom, the cylindricity of that feature can vary by 20 thousandths of an inch. So if you think about it, if we had a virtual cylinder, we can put this inside of this. That would be just a little bit larger than that, with a variation of 20 thousandths of an inch. Conceivably, we could drop that pin in a no-go or go or no-go sort of situation there, and it should be able to pass through that if it's within tolerance of this feature control frame, as it's stated. It should be able to pass through that cylinder. That's what that means. Flatness is something you might define. Flatness of this surface, which means the surface as measured from itself could be flat within a precision of 0.02 inches or 20 thousandths of an inch. And if you want to take these feature control frames and make modifications to them, all you have to do is click on that and it brings up the frame, double click on it and brings up the frame. But how do you get that in there initially? So I'm going to go ahead and take that frame, I'm going to delete it, and where you find this is you go to annotation. It's on your annotation portion of your command manager, and it's called geometric tolerance. And what this geometric tolerance does is it produces a feature control frame. You start over here on the left and work your way to the right. You want to go to your cylinder, or your symbol, I'm sorry, and these are some of the more common ones: position, cylindricity, flatness is what we want. So we're going to pick out flatness, and we're going to type in a tolerance of 0.020, and then go to OK. And what it does is it gives you that feature control frame. Before you do OK, it's probably a good idea to, if you can pull that off to the side and work with it a little bit. It's kind of like annotation text with the leader line on it. If you get close to an object, it gives you the ability to click on that object and then drop that into place. And once you're all done, go to the green check mark, rearrange the furniture in a manner you see fit in order to make sure that, along with dimensioning strategies, you want to make sure that it all fits in there correctly. If you need to make modifications to it, again, just double click on it and go up here, and you can continue to add elements to it if you like. So that's a basic start for the feature control frame. In our next video, we're going to talk about datums and how datums work. Right now we don't have any measuring surfaces, and we talked about datums very briefly in our first film, but what we don't have here is surfaces that these feature control frames reference. For instance, this feature control frame would reference itself. It's got to be flat. If measured by the surface itself, it's got to be flat within a certain tolerance of 20 thousandths of an inch. So it's referring to the surface that's up here. Typically, you have datums that would go with that, and in a block item like this, we're going to put in 3 datums, and then we're going to better define those here in the next few videos.